Dear students, in this video we are going to see Cauchy's integral formula and the Cauchy's integral formula for derivatives and the problems on that. Okay, first we see this theorem. Suppose C is a simple closed curve and the function f of z is analytic on a region containing C and its interior. We assume C is oriented counterclockwise. Then for any z0 inside C, the value of the function at z0 is equal to 1 over 2 pi I integral over C f of z by z minus z0 dz. Okay. Now here this is the given region C. You see the arrow. This is anti-clockwise rotating, and z0 is a point. Now this is the Cauchy's integral formula. The value of the function at the point A is equal to 1 over 2 pi I integral over C f of z divided by z minus a dz. Now, the second formula is nothing but the Cauchy's integral formula for derivatives. That is, the function and the derivative at A is equal to n factorial divided by 2 pi I integral over gamma f of z by z minus a over n plus 1 dz. Okay. Now, evaluate integral over C sin 3z divided by z plus pi over 2 dz, where C is a circle, mod z is equal to 5. Okay. Now, we know that what is Cauchy's integral formula? That is, integral over C f of z by z minus a dz is equal to 2 pi I f of a. Actually, here we have cross multiplied this 2 pi I with f of a. That's why here we are getting f of a multiplied 2 pi I is equal to, this is the required value of the integration. That is asked in the question. That's why we cross multiply. So what we have to do to find the integral value, we have to find f of a and you multiply with 2 pi I. Okay. Now here what is C? That is mod z equal to 5. Center is 0 and radius is 5. Now here to find f of a, first you write the value, you write the point. What is a? Here z plus pi over 2 is given in the denominator, which means here you compare z minus a and z plus pi over 2. That's why a is equal to minus pi over 2. Okay. Now what is the value of the function f of z? That is here in the numerator, f of z is equal to sin 3z. That is f of z equal to sin 3z. Okay. So that now we have to check the point a is equal to minus pi over 2 is lies inside or not inside. Yes, it is inside, because here 0, 0 is the center and radius is 5, but the value of the point is minus pi over 2, that is minus 1.5 approximately. But here radius is 5, so that definitely this point lies inside. See, before we apply the Cauchy's integral formula, first we have to check the point is lies inside. If the point lies inside, then only we can proceed. We can apply the Cauchy's integral formula. Why? Here you see the rule. We assume that C is oriented counterclockwise, then for any point z0 inside C, then we can apply the Cauchy's integral formula. That's why I am telling, first you check that the point A is equal to minus pi over 2 lies inside or not inside. If it is inside, okay, we can proceed. Okay. Now we have confirmed that A is equal to minus pi over 2 is inside the circle. Okay. Now what is f of A? See, f of z, we know that in f of z you replace z by a, that is minus pi over 2. Now what we are doing here, f of a is equal to sine of minus pi over 2 multiply 3, because here we have 3z, that's why 3 minus 3 pi over 2. Okay, so that's why we get f of a is equal to 1, that is sine minus 3 pi over 2 is 1. To find this value, you can use your calculator. Keep your calculator in the radian mode, then you find the value of this one, that is 1. Okay. Now you can substitute here. So now by cos integral formula, what is the value of this integration? That is equal to, now you see here 2 pi I multiply f of a. What is f of a? F of a is 1. You substitute here both. So 2 pi I multiply 1, which means 2 pi I. So that is the value of the given integral. Okay, that's it. Now you see the another question. Now you see here, compute integral over c cos z divided by z multiply z squared plus 8 dz over the contour. Okay, so over the contour, here they given the picture in this question. Okay, so now this is our contour. See, it is anti-clockwise. This is our contour. Okay, now first what we have to do, you have to write the function and the points, then you have to check the points with inside or outside, lies inside or outside. Okay, now you see here, what is the function? F of z equal to cos z divided by z squared plus 8. F of z is analytic on and inside the curve. See, okay, that is the roots of z squared plus 8 are outside the curve. So we rewrite the integral. Okay, here you have to understand that. Now you see here we have cos z divided by z squared plus 8. Okay, here z minus 0. So this point 0 is lies inside. That's why here put dot mark. Okay, but z squared plus 8, if you take, what are the values of z here? What are the values of z here? If you write in factor form, see here, if you write this z squared plus 8 as z squared is equal to minus 8, then z equal to plus or minus I 2 root 2. So this point definitely outside the contour. See here, here and here. Okay, outside the contour. So that what you do, cosine z and z squared plus 8, you combine and write as f of z. Okay, that's why we rewrite the integral. You see here, so we rewrite the integral so that, see, which point is lies inside the contour. See the point here, what is that? Z means z minus 0. Okay, so here no doubt 0 is lies inside. Okay, that's why you write z minus 0, that is z in the denominator, then all the remaining you write in the numerator. So now what is your f of z? That's why here we are writing f of z is equal to cosine z divided by z squared plus 8. Okay, after finding the point is lies inside, what you do here, the point is 0. So now we have to find f of 0, because the value of this integral is equal to 2 pi I multiply f of a. 2 pi I multiply f of a. A is 0. Okay, a lies inside. See, from here I can confirm that here is it not or a. I can say that is 0 lies inside. That's why I calculate 2 pi I f of 0. Okay, it's equal to 2 pi I. What is f of 0? You know that f of z. Here put 0. Here put 0 for z. Okay, so that cos 0 is 1 divided by 0 plus 8. So 1 over 8. That is here f of 0. 1 over 8. So answer is pi I over 4. This is the value of the integral after applying the cos integral formula. That's it. Now you see, evaluate integral over c z e power z divided by z squared plus 1 dz. Okay, now what is the contour? C is mod z equal to 2, which is circle. See, radius 2 and center 0 and oriented counterclockwise. That is always same. Now first, how we can do this? See, first we have to see the cos integral formula. Here what is the degree of this term in the denominator? 1. Okay, now you see here, and you see here degree of z is also 1. Now what is given here? Z e to the power z divided by z squared plus 1. So first what we have to do, use partial fraction and then you divide into two terms. Now you see 1 by z squared plus 1 equal to 1 by z squared minus I squared. Then write this like this. Then you do partial fraction. You can find value of a is I over 2, value of b is minus I over 2. Then you can write like this. Okay. Now after writing this, here we have to split this integral into two parts. Yes. Okay, 2 parts. Okay, now what is the function in each integral you have to identify? That is z e power z, z e power z. How we identify z e power z? Because this point z is minus I here. You see minus I. Definitely this is inside the circle. Okay, because radius is 2, center is 0. Okay, but this is minus I, definitely inside, and here this is plus I, definitely inside. Okay, that's why here we are doing the, see here itself we know that when you write these two, we know that z plus I, z minus I, definitely these are the 2 points that are going to check whether it is inside or outside. Yes, this also inside, this also inside. So now that's why we separate into 2 integrals. Then you write f of that. F of that is z e power z. Okay, here what is the point? Here what is the point? Both I and minus I are inside C. So here minus I, the point. So you see here for the first integral, so put minus I, then find the value of the function at minus I, then write this one. See, this value is for the first integral. Here what is the value of z? That is I, that is also inside. So now for this second integral, you see, find the value of the function at I, then you write this. Okay, now what you do, actually what is the question? This is the given integral, so you combine both. See, I over 2 this value minus I over 2 this value. So now that's what we are doing here. You substitute these 2 values, this one and this one. Okay, then you simplify it. Your answer is 2 pi I cosine 1. Here also you can find the value of cosine 1 by using the calculator, keeping in radian mode. You can simplify more. Okay, that's it. Now you see here, compute integral over C 1 over z squared plus 4 squared dz over the contours shown. Okay, the picture is given. We have to find the integral of this over C. Okay, C is the given picture. Okay, given contour is this one. Okay, now here by seeing the question itself, we understand that here z square plus 4 whole to the power 2, the degree is 2. So here we cannot apply the causes integral formula, but we can apply the causes integral formula for derivatives. Okay, why? Because here see the degree n plus 1. Okay, more than 1. If here the degree z minus a whole to the power 1, then you apply the causes integral formula. If here degree of this term z minus a is more than 1, you go for the causes integral formula for derivatives. Okay, now you see here the degree is 2. Okay, here degree is n plus 1 in the general rule. So what is n? N is 1. If you compare this, see, n plus 1 is equal to 2. So n is 1. Okay, now see here, first you factor this z square plus 4, so that you will get z minus 2i whole square, z plus 2i whole square. And you see here, this is the point. Here 2i, here minus 2i. Now here 2i, here minus 2i. Okay, which is inside? 2i is inside, which means z minus 2i squared is inside. So you can keep this in the denominator. But this is not inside, so you write that is your function f of z equal to 1 over z plus 2i whole square. Understand? Because this point is inside, so you write this in the denominator. This point is not inside. Okay, minus 2i is not inside. Okay, minus 2i is not inside. Therefore, you take this as a function. Okay, because your function is 1 over z square plus 4 whole square integrand, that is given in the question. Okay, now that's why you see here integral over C 1 by z square plus 4 whole square dz is equal to, you write this. See, f of z. What is f of z? This is your f of z, because this point is not inside. Okay, so now this point is inside, so which means a is 2i. So now you apply the rule. See here, that's why we rewrite the rule. This is the required integral. That's why f nth derivative at a multiply 2 pi I, then divide by n factorial. Okay, here that's why 2 pi I f dash of 2i. Why? Because n is equal to 1. Here nth derivative n is 1. That's why you make the derivative of this function, then substitute 2i, you find this value. Understand? See, that's what we are doing here. Derivative, and you substitute is equal to 2i, then you find the value, then you simplify it. That is your final answer, pi over 6. That's it. Thank you.